Hello everyone. Today I Vaishanwi Pachpute with my team members Smita, Titkare, Gyatri, Lokare and Shehbaz going to present a presentation on generating voltmeter under guidance of our guide Mrs. Dent ma'am. So, what is generating voltmeter? The generating voltmeter is a variable capacitor electrostatic voltage generator, which basically generates a current proportional to the applied voltage under measurement, and it is used for measuring high DC voltages. The arrangements given below provides loss-free measurement of DC voltages. Now, let's move on to the next topic, principle of generating voltmeter. The basic principle of generating voltmeter is rate of change of capacitance of a capacitor with respect to time causes a current to flow through it, and this current is proportional to the voltage applied to the variable capacitance. If the charge stored in a capacitance of capacitance C is given by Q is equal to CV, and if the capacitance varies with respect to time when connected to the source voltage V, then the current through the capacitor will be I is equal to dq by dt, which is equal to V dc by dt plus C dV by dt. But for DC voltages, dV by dt is equal to 0. Therefore, we get I is equal to V into dc by dt, where V is a terminal voltage and C is terminal single plate capacitance. This is the schematic diagram of generating voltmeter, which shows the constructional details of generating voltmeter. Here S1 and S2 are fixed electrodes. S0 is a rotor and S3 is HV electrode, that is high voltage electrode. This leads me to the next topic, construction of generating voltmeter. Generating voltmeter is used when source loading is prohibited, like in case of Van de Graaff generator, or when direct connection to high voltage source is to be avoided. The generator is driven by an external synchronous or constant speed motor, so it does not absorb power from the measuring voltage source. The high voltage source is connected to a disc electrode S3, which is kept at a fixed distance on the axis of the other low voltage electrodes, that is S0, S1 and S3. Also, the rotor S0 is driven at a constant speed. The speed can be 1500, 1800, 3000 and 3600 rpm. The motor vanes of S0 cause a periodic change in capacitance between insulated disc S2 and the HV electrode SC. Let us see the various constructional details that will be emerging in the form of animation in this video.
On this diagram, first and foremost, I am going to highlight the various electrodes. You can see the highlighted portion in the red color, the cross-sectional view of disc S3, which is a high voltage electrode. Its shape is visible at the bottom in the blue colored highlight. So this is S3 electrode. It will be fixed, and that's what we can see, both of them together. Then next electrode is S1. We can see that electrode S1 is in the form of a disc but having slots cut across through this, and it has got a provision in the center through its axis, through which the motor shaft is free to move. It is installed in such a manner that the electrode remains fixed, but a motor shaft can pass through it. So that's why there is a hole in the axis in the center of this electrode S1. Similar shape is that of electrode S2, but this S2 is in the form of a disc without any slots cut across it. There is a provision for the motor shaft to pass through it. So both these electrodes along with high voltage electrode S3, these are fixed electrodes. Then the only rotating electrode is that of S0. S0 electrode is fixed to the synchronous motor shaft, and it is placed at a fixed distance from the high voltage electrode. The shape of the rotor vanes S0 is in the form of fan blades as visible on the bottom right side. Apart from these electrodes, which are in the form of coaxial discs, we have a motor. It's a constant speed motor, either a synchronous motor or other form of motor which can run at a constant speed and hence obtain a constant time rate of change of capacitance induced across the electrodes S1 and S2. Then we have a rectifier circuit which will enable measuring the rectified current induced due to time rate of change of capacitance, as we have seen the equation earlier. And lastly, the microammeter, which will be responsible for giving us current directly calibrated in terms of unknown high DC voltages. So the RMS current equation that we have mentioned in the earlier slide is again reproduced here as equal to V Cm omega upon root 2, where omega depends upon the speed of the motor, which will remain constant, and Cm is the maximum value of capacitance that will be induced across electrode S2 with respect to S1. Kindly observe that only electrode S0 is having rotational axis. It will be rotating while all other electrodes will be fixed. So as electrode S0 rotates, the electric field lines emerging from high voltage electrode S3, they will be cut across as they approach electrode S2 all the way to the right hand side, and in doing so a variable capacitance will be induced onto electrode S2. So here we can see as it rotates, it will cut across the field elements and there is change in capacitance obtained from such a arrangement.
Now we will see the circuit operation. Rotation of S0 produces sinusoidal variation in capacitance. AC current proportional to the external voltage is generated due to that through the resistance R and is proportional and is rectified and read a moving coil instrument. An amplifier is needed if shunt capacitance is larger or longer leads are used for connection. Also, the instrument is calibrated using a potential divider or spark gap. Now moving on to the next slide. Working of generating voltmeter. The generating voltmeter employ rotating sectors or vanes for variation of capacitance. As we have seen in the schematic diagram, the high voltage source is connected to a disc electrode S3 and it is kept at a fixed distance on the axis of the other low voltage electrodes, that is S0, S1 and S2. So the rotor S0 is driven at a constant and suitable speed by a synchronous motor. The speed can be 1500, 1800, 3000 or 3600 rpm. So the rotor vanes of S0 cause periodic change in capacitance between the insulated disc S2 and the high voltage electrode S3. The shape and the number of vanes of S0 and S1 are so designed that they produce sinusoidal variation in this capacitance. So, the generated AC current through the resistance R is rectified and read by the moving coil instrument. An amplifier is needed if the shunt capacitance is large, or longer leads are used for the connection to rectifier and meter. The instrument is calibrated using a potential divider or spear cap. The meter scale is linear and its range can be extended by extrapolation. So our next topic is advantages. In the advantages of generating voltmeter, the main advantage is no direct connection to high voltage electrode. Also, scale is linear and extension of range is easy. And a very convenient instrument for electrostatic devices such as Van de Graaff generator and particle accelerators. Also, no source loading is done by the meter. There are some disadvantages also, which includes the generating voltmeter require calibration. It is one of the disadvantages of generating voltmeter. Also, disturbance in position and mounting of the electrodes make the calibration invalid. Also, careful construction is needed and is a cumbersome instrument requiring an auxiliary drive. These are some applications of generating voltmeter. The generating principle is used when direct loading or direct connection is to be avoided. It generates current proportional to the voltage under measurement. This arrangement provides loss-free measurement of DC and AC voltages. It is driven by synchronous motor, so does not absorb power from voltage measuring source. The high voltage electrode and the grounded electrode in fact constitute a capacitance system. This is the work distribution among the group members. Smita Titkare has prepared the PPT. Vaishanwi Pachpute has presented with the PPT. Gyatri Lokare has made animation video. Shehbaz has been contributed towards query resolution. These are some questions that can be asked on this PPT. What is the size of electrode that can be used? What is Van de Graaff generator? Why the generator doesn't absorb power from the measuring voltage source? And what is calibration? So, in conclusion, generating voltmeter is used for applications where direct contact with high voltage terminal is not possible. A current proportional to unknown voltage is generated by variable capacitor electrostatic voltage generator. The main advantage are no source loading and linear range. The main limitation is sensitivity to location and mounting. Thank you.